Hello, hello. All right, so let's continue on. Um, so we last left off with our program having this big if, else if, else conditional, right? Where we check to see the first letter of our card name string is either K, Q, J, A, and we'd actually just assign some value to val based off of that. And if we have no other option, we would just fall through and by default with this else statement, convert that string to an integer, right? Um, and then after that, based off of whatever value we have, we either say the count has gone up, or if the value is exactly 10, the count has gone down, and for all other values, we just don't do anything. So yeah, the book is now going into this discussion of switch statements, right? And so I think it's kind of worth reading this part to understand the difference. So let's do that together. Pulling the old switcheroo. Sometimes when you're writing conditional logic, you need to check the value of the same variable over and over again. To prevent you from having to write lots and lots of if statements, the C language gives you another option, the switch statement. So here's a key thing here. It's this new sort of way of writing conditionals called the switch statement is here to help us when when we find ourselves writing a lot of if statements, just like up here, right? We have a lot of if statements. Technically, I count else if as if statements. So there could be an easier, better way to write this. Maybe not necessarily easier, but at least create code that is more readable. So let's continue. The switch statement is kind of like an if statement, except it can test for multiple values of a single variable. So given a variable, we can then check to see if it matches a specific value that we're expecting, right? So in this case, we have a switch statement here that checks for whatever value that is currently assigned into the train variable. And we already know that this train variable can be either one of the three values here, 37, 65, 12, or it could be some other value that we don't know about, right? In this case, how we write the statement for a value that we expect, we prefix it with, or I guess precede it with the case keyword, right? So case 37, and then we have a colon. That tells us, okay, if train is 37, what do? Well, we will just add 50 to the value currently stored in the winnings variable, right? Um, if our value is 65, well, guess what? We hit the jackpot. And we add 80 to the current value in our winnings variable. And if our train value is at 12, well, then we only add 20. Otherwise, we don't add anything. We lose everything, right? Which is zero. And um, interestingly, you notice that there's this break statement here, right? The break is actually a special keyword that allows you to sort of uh, like move away from the current block of code. So in this case, by saying break, we get out of the switch statement now. So if we hit case 37, meaning that 37 is in train, we perform our logic and then we encounter the break statement. And when we encounter that, then we kind of take a shortcut and move down to the next line outside of our switch statement. So depending on the program you're writing, having a break or not having a break statement can actually yield different effects. And sometimes even forgetting to have a break keyword inside a switch, for example, can lead to weird bugs. So for example, we don't know here, like notice that there is no break statement here or keyword here. And so we're not really sure whether or not, well, is this a bug? Because guess what? If we read this code, right, um, we'll most likely, depending on what's going on, we could end up in maybe not in this situation, but we could end up actually falling through and executing more lines, right? Um, so yeah, it's just fortunately that's I don't think that's the case. So oh wait, it might be. Then the computer hits a switch statement. It checks the value it was given, and then looks for a matching case. When it finds one, it runs all of the code that follows it until it reaches a break statement. Yep. So there you go. The computer keeps going until it is told to break out of the switch statement. Interesting. Huh, okay. Missing breaks can make your code buggy. Most C programs have a break at the end of each case section to make the code easier to understand, even at the cost of some efficiency. All right, interesting. Okay, well, guess what? Let's actually test this a little bit, right? Let's test what happens when we don't have a break like this. What kind of we'll just like make this example here. Like, we'll make it runnable. So let's write that code. So we're going to kind of take a tangent away from our card program, right? And let's create a new project called switch test. And we'll have a new a file, main.c, okay? And of course, like always, it's worth just typing it all out. We'll include stdio.h, right? And then we'll define our main function, and we'll say return 0 at the last line. So let's just write this piece of code here immediately. Let me just minimize that. Okay, so and we don't have our variables defined just yet. We'll just copy whatever's in this page here, and then we'll like fill in the rest later. Okay, so let's see. We have switch, right? Train. Okay. Then we'll take into consideration that train could be 37. So what do we do when train happens to be 37? Well, we'll increment winnings, right, by 50. And we'll have a break. And we'll also consider when train is 65, right? And we'll actually put the string in the screen that says jackpot, okay? And then we'll increment, or not increment, or add, right, to winnings, 80, right? Actually, interesting. I wonder what is the definition of increment, because I keep saying increment by 50, increment by 68, but I always think that increment just means by like adding one. So let's see. Increment definition. The process of increasing in number, size, quantity, or extent. Oh, so I guess I was using it right. I always thought that increment means to like just add by one, right? Increment. But then I guess if I think about it, we always say increment by one. So I'm technically correct when I say increment by 50, increment by 80. Okay, just making sure I'm using the right words. So, okay, now we'll check to see if train is 12, right? What will we do? We'll increment winnings by 20, and we'll have a break statement or a keyword. And default, meaning that if train happens to not be 37, 65, or 12, we'll just execute whatever comes after default, which is going to set winnings to 0. Okay, now it looks like we don't have, right? We don't have two variables defined here, train and winnings. So I'm going to just say, I'm just going to declare that, right? So int train, and I'll just say it's going to be 37, just a test, right? And then I'll start winnings as an int. I'll start it at 0. No, let's start at 10, okay? And then at the end here, we'll print something. We'll print train value is %d, winnings are %d, new line, right? And we'll say train winnings. Okay? All right. So let's see if I can make this better. Let's see. Train winnings. We'll keep it like this. Okay? So if we look at this code and we execute it, right, in our heads, if train is 37, that means we'll increment winnings by 50, and then we break. So that means we move out of the switch statement, right? We move out of it into the print statement. And we'll say train value is the value train placed into here, which is going to be 37. And then winnings are going to be 10, right? 10 currently. Plus 50 is going to be 60. So train value is 37. Winnings are 60. So let's quickly compile that. So if we were to go one directory, then go to our switch test, and we do gcc main.c. We'll output that as switch test, right? And then we'll execute that. Okay, so we get train value is 37, winnings are 60. Cool. So what happens now if we change train to 65? What do you think we'll get? 90, right? Based off of this, right? Will it come to here? Right? So if we're unsure, the one thing that we should always do is write these types of tests, right? These types of little programs here to kind of check our understanding. So let's just run that, right? So train, the value of train, switch to train is 65. We want to see jackpot, right? And then we want to see something that's at least 90. But we're not sure whether or not that's going to continue to increment here, right? So let's compile again, and then let's execute this program. Okay, so jackpot. Okay, that's correct. Our train value is 65. That's correct. But our winnings are 110. Is that right? Well, we have winnings to be 10 here, and then since it's 65, we put jackpot. Winnings at this moment is 10, right? When we have this line here, it's 10 plus 80 is 90. But then we fall into this spot here where we say winnings is now, we have 90 plus 20, which is now 110. Then we finally have a break here, and we fall out of the switch statement. And now we have this output here that says train value is, well, it's 65, but winnings are, in this case, starting from 10, 65, we fall into here, that becomes 90. Then since we don't have a break statement, we're going to fall into this case 12 here, and that'll be 90 plus 20, which is 110, and then we finally hit our break statement. So depending on not, this could be a bug, right? So what would be the fix? Well, the fix would just be to add a break here. If it's the intention is to not execute code after the increment of 80. And while we're at it, good practice, we can also just add break here too at default, right? Even though technically it's not needed because, default is just going to, if you're looking at things top down, default is just going to get out of the switch statement, right? So let's try that. Okay, so we fixed it, right? Train value is 65, winnings are 90. Now, I said earlier just now that default doesn't really matter if we have break here, but it's only for this case because default is actually at the last check of our switch statement. But let's say we had default instead of being down here, but up here, right? and let's say we never had break, what would actually happen? If we never had 37, 65, or 12, but rather, let's just say 3, right? What would we expect our winnings to be? So let's try it. So we'll compile our program, and then we'll execute again. The train value is 3, but our winnings are 50, right? It should be 0. It should be set to 0. We should have lost our money. I guess I'm just going to say this as money or points or whatever, right? We started at 10. I intended that, if it's not one of these three numbers, we should lose everything, right? But that's why we set winnings to 0. But then we're ending up with 50. Well, that makes sense because if train is 3, right, we'll hit the default case, right, which is 0, right? And then we never broke out of it, so we keep going down to 50, right? And so then we add 0, right? We set 0. 0 plus 50 is 50, and then we break. So that's why breaks can kind of cause some issues if you're not, or if you're forgetting them, right? Or if you're putting them in, for example, like this, and you don't intend for it to break, which is, I think, kind of rare. But you can also do something like this, right? Like case 70, right? We basically what we want here is that if trained is 65 or 70, we still want it to execute the same code, right? So that is a pattern where you want two values to kind of handle the same piece of code, right? So if we had 70 here, right, we would expect jackpot to be 90 with this jackpot text if train is 70. So let's check that. That's true. Train is 70, winnings are 90. So that's what I had to say, or have to say about the switch statement. Okay, so let's keep going. Yeah, so let's do this exercise now that we're familiar with the switch statement. Can we rewrite this code using the switch statement? Write your answer below. Okay, so let's pivot back to our cards code. Right, so I'll just close this window and just go back to here. All right, so let's write a switch statement. What is it that we are checking? Like what variable in this case, right? We're checking the first character in the card name string. So remember, your switch statement contains the variable you're checking. So in this case, we'll have switch card name 0, right? And then we'll be checking for everything that is valid to be in card name at 0, right? So in this case, we can say case K, right? Could be val equals 10. And then we say break because we don't want code to execute after that. We want to get out of our switch statement, right? We'll say case Q, val equals 10. And we'll break. And then we'll say case J, right? Val, oops, yeah, val is going to be 10. We'll break. We'll say case, see, A, right? Say val is now 10. Oh, not 10, 11. And then we'll break. And then by default, which is equivalent to else, if we think about it, right? By default, right? Meaning else, if none of the other values apply, we want to say val is just a conversion of the string to an integer. A to I is the function that will convert a string to an integer. So that's it, and we'll just break. Right? So then we can get rid of all this here. This is old stuff. And now we have something a little bit cleaner. Okay, let me respond to a text. Okay, is this the right answer? Well, let's test it first before we actually look at the answer, right? So let's run our card program again. So it's in C, Project C cards. So are we at the right place? Project C switch test. Nope. We'll go up one directory. We'll list and we find our directory. So we change our directory, cards, list again. And we can't just run cards, right? We have to recompile this. So it'll be GCC, right? Main.c dash O cards. Okay, that's great. Now we'll execute cards, and it's going to ask us for a card name. Well, I'm going to say I'll put in king. Count has gone down. Is that correct? Well, if val is 10, right? We'll break. Okay, and then val is 10, so count has gone down. Okay, that's pretty good. Okay, now let's try another case. We'll execute the program. We never made any changes, so we don't need to compile. Let's do A. Okay, nothing happened because going back to our program, we've only checked to see if value is between 3, like inclusive, and 6. Basically greater than 2 and less than 7, right? Which A is not, right? Because A assigns 11 to val. And then else, if val is 10, the count has gone down. Well, val's 11, so that doesn't work, so we don't do anything. Cool. Last, we'll say maybe 3, and count has gone up, which is expected, right? I wonder what happens if we do 2. Okay, nothing happens. Maybe 7. So we're testing boundary cases right now. So it's good to always test boundary cases too. Okay, how about something that doesn't even apply? L. Okay, nothing happened. How about ABC? Okay, nothing happens. How about 1, 2, 3, ABC? Nothing happened. Okay, I think I've had my fill for testing a little. So, yeah, let's see what they got here. Okay, so they were cleaner than me actually. Look at this. They actually at least the authors of the book decided that val equals 10 was quite repetitive. So they did the trick that I had shown earlier is to just consolidate this way, right? Since we're executing the same val equals 10 logic, we can just say K, Q, J all fall into this logic here. So that's correct. We got that correct technically. And it looks like they didn't break on the default, but I like to do that out of habit. Pretty cool. Okay. All right. So, the main ideas, right? Switch statements can replace a sequence of if statements. Switch statements check a single value. The computer will start to run code at the first matching case statement, and then it will continue to run until it reaches a break or gets to the end of the switch statement. Okay? Check that you've included breaks in the right place. Otherwise, your switches will be buggy. Cool. All right. So why would I use a switch statement instead of an if? If you're performing multiple checks on the same variable, you might want to use a switch statement, which is what we were doing, right? Like we were performing multiple checks on the first element of this card name array. So it was really repetitive. So if card name at 0 equals K, if card name 0 equals. So that gets repetitive. So maybe to try to simplify, we use switch statements. So what are the advantages of using a switch statement? Well, there are several. First, clarity. It is clear that an entire block of code is processing a single variable. That's not so obvious if you have a sequence of if statements. True, I agree. Secondly, you can use fall through logic to reuse sections of code for different cases. Like this one right here. This is fall through logic, right? Does the switch statement have to check a variable? Can it check a value? Yes, it can. The switch statement will simply check that two values are equal. True. Can I check strings in the switch statement? No, you can't use a switch statement to check or to check a string of characters or any kind of array. The switch statement must only check a single value, or will only check a single value, right? And technically, we did. We only checked for the single value, the single character here. So okay, all right. So we're gonna do loops now, huh? Looks like sometimes once is not enough. Okay, before we do that, I'd like to actually commit some of the code that we've written, right? Okay, we'll just add cards and switch test, two folders, right? Check it out, great. Then we'll say uh, stuff about switch statements. Okay, cool. So we're at a good state. Okay. Sometimes once is not enough. So loops, how do we do like re- things repeatedly, right? And if you're coming from Python, JavaScript, that's like super obvious. You have like while loops, for loops. If this is your first language, C, uh, basically a while loop and a for loop are things that you would normally write code over and over and over to do, but you can actually kind of automate some of that repetitiveness in the loop. Like it'll just always execute for some number of times. Not sure if I really described that well, but um, you'll see. So, you've learned a lot about the C language, but there are still some important things to learn. You've seen how to write programs for many different situations, but there's one fundamental thing that we haven't really looked at yet. What if you want your program to do something again and again and again? Well, we can use while loops in C. Loops are a special type of control statement. A control statement decides if a section of code will be run. But a loop, right? So wait, let me back up. So if statements, switch statements, those are all control statements, right? So that's like check some logic, decide whether or not it's appropriate to actually execute your code. But a loop decides how many times a piece of code will run, right? The most basic kind of loop. This is so annoying. All right. The most basic kind of loop in C is the while loop. A while loop runs code over and over as long as some condition remains true. Okay. So here's what a while loop looks like. So it checks some condition while some condition is true, right? A while loop runs code over and over again as long as some condition is true. So as long as this condition in here, which is going to evaluate to a Boolean, right? It'll execute this whatever's inside this block right here, denoted by the opening and closing braces, right? So we call that the body of the loop. See, the body is between the braces. If you have only one line in the body, you don't need the braces. I still don't recommend any of that stuff, right? I always like for me, I can't. My eyes cannot see like if whether or not something is part of a body of a while loop or a for loop or an if statement if I just don't have braces. And I just think that like not having braces is just like a source of bugs. When it gets to the end of the body, the computer checks if the loop condition is still true. If it is, the code body runs again. So I think that's a fair way to say it, right? So you execute. So how the computer will do it is that in a while loop, is that the body of the loop is going to execute once, right? And then once it's done with the body, once it reaches like let's just pretend the the ending brace, it's gonna go like think of it as like going back up to check to see if this condition is still true. And if it's still true, then it's going to execute the body again one more time, right? If it is not true, then it's actually not going to execute this while loop anymore. It'll execute the next line following that while loop block, right? And basically, when it's true and it executes the loop body, it does the same thing over again. At the very end, it's going to go back up and kind of say, oh, well, is this condition true now still? If so, then execute the body again. Otherwise, get out of the loop and execute the next line that follows. All right. So this explains a do-while loop here. It's kind of rare that I guess I use it, but basically it allows you to execute the body first and then check the condition. Yeah. So loops often follow the same structure, right? So it's like I said, you know, have some condition, right? Check for that in the while block and then execute the code between that if it's true. Otherwise, move out, right? And I can just give an example. So let's give an example with the while loop, right? So let me just create a new project. While loops C. I don't need to say C. I can just say while loops. Let's just create a new file, main.c. And then we'll do the same thing. Get some reps in, right? Okay, one adjustment I want to make in my VS Code is I don't like this mini map. I don't think it gives us enough space to work, before we cover it. So I'm going to turn that off. And how we turn off this mini map here, right? The sidebar here is through our settings. It's called mini map. So go settings, mini map. Minimap enable, disable it. Now we've gained some pixels back. Okay, see, it shrunk down to this. So include stdio.h, right, into main. Okay, so let's just have a simple loop that counts some variable up to a certain point, right? So I'm gonna just write that real quick, and then we'll kind of go over that together. So I'll start some variable called int current count is going to be 0, and we're going to count to 10, right? So it's from 0 to 10, inclusive, right? So while current count is less than or equal to 10, right? I want to just print out that number, right? Print f %d, and I'll print it in a new line, right? As like its own line. So that's a placeholder. So we'll give that value to the placeholder. And then we'll execute this loop. I'll return 0. So it's a simple loop. Maybe I should just, whoop, we forgot to increment, right? Oh. Just so you know, this plus plus here is notation for incrementing by 1, right? So I could do something like this, right? That's the same thing, but I think I'm gonna keep it short and a standard convention to just do plus plus. Okay, so we're gonna execute this loop about I guess 11 times, right? Starting from 0. So we'll print 0 because current count is 0 and it's less than or equal to 10. And then we'll increment current count by 1, so 0 becomes 1. Then we go back up and check, is current count less than or equal to 10? Well, current count is 1 right now, right? So then that's true. It is less than or equal to 10. So then we execute this loop body. And we keep doing that over and over again, incrementing current count until up to the point where, let's say, well, current count is now 10. Current count is less than or equal to 10. And so that's true. So we execute the loop body and then we increment current count by 1 more, which takes it to 11, right? But we're not done yet. We have to check where to go. Like pretend you're going back up. If it's 11, go back up to the while loop, check. Current count is currently 11. Is 11 less than or equal to 10? No, it's not. That is false. So then we get out of this loop and we go and execute the next line, which is return 0, and that our program just ends because of that, right? So let's actually try that out. Let's run this program. Let's see where we're at. C while loops, right? And we'll compile the program. So gcc main.c-o, which is our custom output file name, and I'm just saying loop while loops. right? Now execute while loops now. I'll trust that it was good because I got no output. And here we go. So we executed this loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, right? Because we started at 0 and we counted up to 10 inclusive, right? And it's doing exactly what we expected because yeah, our Boolean, our condition, right, that we evaluated into a Boolean is true, in this case 1, right? Common like thing that people like to do if they want to create an infinite loop, right, is that they just kind of always make it true, right? So let's do this while 1, right? While 1 means that while always true, because in C there's no real Boolean. It's just either 0 or 1, that or 0 or non-zero, right? 0 being false, non-zero being true. So I can just even say like this, while 99, right? That will cause this loop to execute infinitely because 99 will always evaluate to some truthy value. So we compile that and notice that we're in an infinite loop. We keep incrementing this count, right? And then at some point it's going to turn negative because we've hit like the limits of what an integer can represent, right? And you can consult documentation for what limits are. So yeah, so let's change this back to current count less than equals 10. So that's like your basic while loop. It allows you to do repetitive things in a tighter like manner. So yeah. Okay. So this is another case of like break, right? You can like exit, or you can break out of a loop pretty early without having the condition evaluate to false. Like you can actually end the loop early without current count, in this case having to be 11, right, and above, right? How you can do that is by using the break statement, just like the same one with the switch, right? Again, break statement tells the computer, say, get out of this block, go to the next line after the block, right? So let's say this. Suppose now, for some reason, we don't like the number 6, right? And if current count happens to be 6, for example, we just want to break out of this loop here, right? So we can just check that. If current count is 6, right, we can just say break. And that will actually then break out of this while loop by taking it to here, right? So let's execute that. Notice now we don't go through the whole thing anymore, right? We've broken out of our loop because break will take us outside. Now, the point is also to not be confused here is that break doesn't break us out of the ifs at all, right? So breaks only work for like switches and loops, okay? Not if statements. There was a big bug a long time ago because someone thought that they could use break under a if condition and it will break out of the if, right? So most likely they had like some more logic here, and after that more logic here, and they thought that I don't know, but basically breaks are used for loops and switches. Okay, there's another keyword too that allows you to skip the current iteration if a condition is true. And that's the continue keyword, right? That allows you to kind of end this current iteration early, right? And then go to the next iteration, right? So for example, let's say we want to skip 6 altogether, right? Not end the loop when the value is now 6, right? But just skip it. So we can just say continue instead. And what ends up happening is that, okay, once the computer sees the continue keyword, it's gonna just pretend that it's at the end of the loop and goes back up and checks to see whether or not conditions met, right? So in this case now, if we were to run the program, since we're skipping 6, it means that we didn't end up incrementing 6, or we didn't increment the current count, right? Because we skipped it. So we're not going to print it, nor are we going to increment it. So then let's see what happens here. Interesting. What happened, right? It's actually the case that the loop is still running infinitely, right? I made the point where it's like, if the current count is 6, we continue to the next iteration. Well, the next iteration here, our current count is still 6. So 6 is less than or equals to 10. Sure, that's true, right? So we'll come back and we'll check again. If current count is 6, we're going to say continue, meaning that we're going to skip this iteration. So we're going to go back up and check the condition again. Well, what is it? Current count is 6. Is 6 less than or equal to 10? Yes, it is. So we're going to go back in here. We're going to check again. If current count is 6, then we'll continue. And it is still 6. So we never end up changing anything. And that's the reason why we have an infinite loop, right? So let's fix that. So instead of saying, oh, we just want to blindly skip, right? Well, let's say that we just don't want to print this out, right? But we still want to increment, right? So we have some options, right? We can just simply just do current count, right? Is incremented before we skip, right? Or you can just simply keep a temporary variable of O count, right? And then print that one out instead early on, right? And then increment. But that's too much. So I just simply increment this way, right? So we did that. Now we'll see, we actually skipped 6. So we go from 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. So yeah, that's what continues are for. It allows you to skip iterations. Yeah, I think that's good for today. I know we're moving slow, but this is like our chance to understand C. So yeah, see you next time.